All right, folks. Just a couple of examples of some style of problems that you'll see on online homework number 2. So we've got a couple of warm-ups that we'll look at in class, kind of like this. But suppose we've got a number line and we've got equal length segments within that number line, and maybe a few of these tick marks are labeled. And so what if we're asked to locate the 1? So within this number line, figure out where the number 1 should live. Okay, so for this part A, this number line up here, let's see what I've got. I've got these equal length segments. This one is labeled as 2/5, and then this one's labeled as 4/5. Okay, so if I'm looking for the number 1, the number 1 would be equivalent to 5/5, right? We know that if I had a whole, one established whole, and I split it into 5 equal segments, then I'm forming fifths, 5 segments, and then if I collect 5 of them, all 5 of them, I've reestablished my whole or recreated my whole. Okay, so we want to locate where 5/5 is. We know that that's larger than 4/5, so somewhere to the right. What do we know so far? So the length of this segment is the distance between 2/5 and 4/5. So that means the length of this segment should be that same length. And so if I subtract another 2/5, I should be at 0/5 right there. Right, so I want to look for the 1, but I'm kind of backing up. I'm trying to find where the 0 is here, just because it looks like I can. And so what's 0/5? So this might be one of those rules you remember from your youth and say, oh, 0/5 is 0 because my teacher told me if the numerator is 0 and the denominator is something else, then the answer is 0, right? And so that's a true fact, but why is that true according to our definition? So you've got a whole, you split it up into 5 equal pieces, but you don't collect any of them. How much have you collected? Nothing. 0, right? You haven't collected anything. You split a pizza into 5 equal slices, but then you decide not to eat. You eat 0 of those slices. How much of the pizza have you eaten? 0. You've had no pizza. All right, so this is our whole number 0 right there. All right. If I want to figure out where, if I keep going forward, so 0/5, 2/5, 4/5, what would this mark be over here? 6/5. Right, so I've gone a little bit too far. So I know that between 4 and 6 is 5, and so if I split this segment up into 2 equal pieces, then the halfway mark should be 5/5, okay? And 5/5 should be the whole number 1. So I think I've done it. I think I've located the 1. However, this doesn't look beautiful to me. So what I could do right now is if I've kind of my rule of thumb is if I split one segment, split all the segments. And that's where colors are going to come in, because I can use the blue and split this segment. And now that's clear to me. Why is that clear to me? Because to locate the 1, I was trying to utilize the fact that this is 5/5. So can you argue that 5/5 lives between 4/5 and 6/5? Right between. That does make sense, but let's try to rely a little bit more specifically on their definition of fractions. So our definition would say if this is 1, and if we're drawing that conclusion from 5/5, then we should have our whole represented as 5 equal segments. And so by splitting all of these original black segments into these 2 smaller blue segments, now I see that I've got 1, 2, 3, 4, 5 smaller segments forming my whole, and so that I know that I've got 5 equal of those equal segments. I collect all 5 by moving this way, and I've got my 1. Okay, so basically what I'm claiming there is if you're going to split one segment up, you kind of want to go and split the segments around it up as well. Do I have to go crazy and start splitting these? I could, but I'm not really looking for anything beyond there, so kind of just working a little bit too hard at that moment. But there we go. All right. So let's jump down here and try to tackle the same question. So here, this says locate the 1. All right. So again, I could try to find the 0 first if I want to. And in this case, I was at 2/5. It seemed like it was within the scope of this line that was given to me on my paper or on the board here. Over here, I've got 6/9 and 8/9. Okay, so my brain is thinking, using the definition that if I've got a whole and I split it into 9 equal segments, but then collect all 9 of those segments, then that will be my 1, right? So that's reasonable to think about, sort of like a little brain bubble of what we're trying to do. So I'm trying to find 9/9 on this number line. I'm not going to look for 0/9 because it will be way back beyond where the camera is, beyond my room probably. So let's try the approach that we had earlier. Is I'm going to figure out if we're looking at a denominator of 9 here, then that means wherever the 1 lives, wherever the edge of my hole is, we can imagine that our hole has been split into 9 equal pieces. And so if we imagine that, we can imagine that if I moved from wherever 0 lives, so way off camera, wherever 0 lives down there, as I move this way, as soon as I get to here, I've collected 6 out of the 9 segments that we split our hole into. And then if I move over here, I've collected 8 of those 9 segments. And so I'm going to figure out where all 9 of those 9 segments are going to be. So let me figure out what lives between 6 and 8 is 7, right? And so here I've got 1, 2, 3 segments. So where is 7/9 going to live? If I had an even number of segments, let's just say for argument's sake I had 6/9 here and 8/9 there. Right, so let's just say that for a moment. If that were true, then you'd say, well, 6/9, here's a tick mark, there's a tick mark, we're up to 8, so right in between could be 7s. So if you've got an even number of segments, finding sort of the midpoint or the middle one is easy. It's going to be a segment in between there, right? But stepping back to this, I've got 1, 2, 3 of these segments that makes up 2 of my 9s. Okay, so how am I going to find the midpoint of an odd number of segments is kind of count in. So let's say this one and this one, right? So I'm going to move in. Those 2 equal each other out. And then this one, it's got to be the dead center of this one segment. So if you've got an odd number of segments, find sort of the centermost segment and then cut that in half. Alrighty. And so that's 6/9, and then so I'm going to claim that that would be 7/9, 7/9, and then down here I've got 8/9. Okay. So now I see that this distance now is what I need to go over here, right? But what's going on right here is now I have my original length segments, and then I've got these 2 little half segments right there. And I don't love that because they're not the same size. And so let's think about what we said in this previous problem. If you split or break up, maybe split in half, maybe split up to 2, 3, 4 pieces, however many, if you split up a long segment into smaller segments, split up the rest of the segments around there. So I'm going to do these little kind of size marks, about the height of my original black marks, but I'm doing them with a blue marker here. So I'm not sure if those colors are translating great into the screen that you're watching me on, but hopefully if you've got a number line in front of you, you're mimicking along what I've done, and so you've got it, okay? So what I see now is from 6/9 to 7/9 is 3 of these new smaller segments, right? And now they're all equal to the length. And I've kind of extended those probably more than I need. But now I see that 1, 2, 3 of these smaller segments gets me 1/9. Okay, so I want to go from 6/9, I can go 1, 2, 3 small segments to 7/9, 1, 2, 3 small segments to 8/9, and then 1, 2, 3 small segments to 9/9, and 9 out of 9. If we've split up our whole to 9 equal pieces, but then collected all 9 of them, then we've collected our entire whole. All right. And so you might say, did I really need to split up all the segments to locate that? And so the answer to locate it, probably no. You probably could have said, well, to get from 6/9 to that new 7/9, I went 1 of the original segments and then a little half segment. And so from 8/9, couldn't you have gone 1 of the original segments to the black one and then a little half one? So for you as a student, to me, yeah, if the goal is to locate the 1, sure, you could do that. But for you as the teacher, right, which is the goal of all these exercises, getting there, if a student might look at it though and say, well, wait a minute though, why do you have different size segments? I thought the definition talks about equal length segments, right? And so you kind of want to break it down enough to a basic enough level that everything that we're doing here is really obvious, it's really clear, and then we've got it, okay? Yeah. So there we go. All right. I'm going to stop the video so I don't make it too long, but I'm going to erase some of these numbers and do another one where maybe we're looking for a question mark instead of the 1. So maybe there's a tick mark that's already on here that's got a question mark associated with it, and we want to figure out what value would belong there. All right.